Hi, everyone. Good morning. Welcome to another ARD community webcast. Today's topic is business intelligence and data warehouse testing. Today we have Hugh Price on the phone giving the presentation. I'll now turn it over to Hugh. Take it away, Hugh.
Hi, everyone. Okay, so just the format of today. I'm going to present some research done by Sankar Subramaniam, who did a phenomenal job of sort of looking around at this space, did some quite deep research, actually. It was an excellent piece of work. So although it's kind of general stuff, some of it you may know already, I think probably it's worth sharing because I'm in the community. And then what I'm actually going to do is I'm going to probably jump into some pretty hardcore demoing. So for you techies, you might want to just switch to the end because as this is a recording. And I'm just going to kind of show you some of our thinking and where we are, and just show you what the tool looks like and sort of see it slightly in action. Okay. So now Subra basically came up with like an absolute ton of slides. So I will be, or we will be sending out the slide deck as well. So you don't have to, sit and go. I'm not going to go through all these slides because there's an incredible amount of detail in them. I would say that if you look at the marketplace in terms of testing, people tend to focus on the glamour stuff, whether that's sort of testing apps on the phones, which are actually pretty simple to test in reality, down to load testing, which tends to be performed by sort of 3 or 4 people in a testing world. The rest of the world is sitting, maybe doing traditional UI testing, but that is probably only about 10% of an app. Nowadays, most of the work is actually done in these long, complex data change, spanning from a claim coming in, which may have started on a phone, but it could work its way across a very complex estate, until eventually money arrives at a provider. So it's the movement of data around the world that is really where most people. And actually, if you look, I was at a site the other day and they had 600 people in one building just working on ETL, and that was big data testing. And that was a combination of developers and testers. So that's a significant number of people who are, for the most part, manually creating data or hacking data. So let's just carry on a little bit. So some of the numbers in here are quite staggering, really. Total market revenue is expected to be about $4 billion. Which is quite a large amount of money, and if you sort of roll in sort of big data analytics, you're up to some insane amounts, like 187 billion by 2019. So it's a very big and growing area, and as I would say, it's a pretty. Although there are a lot of tools there is very, very, very little in the space of actually testing that the transforms that you've built actually work, and that's kind of where we come in. So. Just a little bit of history. BI reporting, data warehousing, data marts kind of made their appearance. Business intelligence, in-memory RDBMSs. Big data. Everyone's got some kind of Mongo or Cassandra databases now. Everyone's kind of thinking about artificial intelligence, but actually the thing about artificial intelligence, it only really works if you've got good data in there. It's not very good at kind of cleaning up the mess. So it's actually worth spending the time to make sure that you're actually putting good, structured, well-organized data into there. And then, the BI actually is a much more valuable resource to the organizer. Sorry, the BI and artificial intelligence is the kind of a much more valuable output to companies. And even if you just look at, you might have a dashboard on a screen, and if you think about it, if any single piece of point of data is wrong on that dashboard, then the consequences can be astronomical in terms of financial loss or mistakes made or opportunities missed. So what I find is that the rigor of testing that is actually performed in the business intelligence or ETL space is actually much higher than you normally get for a UI. UI, people tend to just test happy paths with not too much negative testing. But when it comes to testing a transform, then the rigor that people put into it is quite extraordinary. So, BI ecosystem, there's all sorts of it, and you'll see some incredibly complex diagrams, in terms of the journey of the data as it kind of moves, from some data ingestion engine whether that's scraping it from databases, scraping it from message libraries, harvesting it from a bunch of data coming in from from healthcare, from pharmacies all over America, things like that. And then once it's in, there are lots and lots of different tools to help you with that. And actually, the top one, reports, is one that sort of doesn't really, a report has a result. You need to check that the result's correct. I mean, and that's absolutely fundamental. And testing of the values of reports is very important. And it's exactly the same methodology whether you're testing a report or testing a big data store to make sure you've got to transform correctly. So some statistics. So big data analytics, the total is 187 billion. Data integration 3.4, business intelligence 26.5. So there are some extraordinarily large numbers in terms of this. So in terms of what we're interested in at CA is a return on investment for customers, so that they can save money. Otherwise, why would you just do it by hand? The amount of money that companies are spending on this is absolutely enormous, and our job is to cut the cost of delivering these solutions significantly by, of course, buying our software and applying our techniques and technologies. So global business intelligence market, it is growing steadily. I mean, this looks pretty linear. It's not exponential, but if you look at the numbers, they are pretty extraordinary in terms of the size. And I'll come to a little slide in a moment, which kind of shows you the richness of the market itself. So just keep going a little bit. A couple more big data slides, just talking about the hardware. And professional services growing as well, but the reality is, professional services, as I think the GSIs have discovered, you can't just keep throwing bodies at a problem. You've got to start thinking a little more based on a structured approach and use technology intelligently. So what I'd prefer to do is just see almost a straight line across the bottom here in terms of being able to do more with the same number of people, because there ain't that we don't have enough people who are specialists in this area. We just don't have enough bodies to be able to do that. There's some stuff here about the different kind of levels of adoption. The reality is, everyone's using it nowadays. I mean, pretty much any process. You used to stuck it in transactional databases, but it's so much easier now just to spin up a document schema or a graph schema and just actually pile that data in and just start scraping it into something that's a bit structured. I mean, you've got products like Splunk, etc., which are kind of built on this kind of concept as well. So, the harvesting of data is now just sort of almost the norm when it comes to, how IT organizations implement their systems. This is business analytics software. So this is the actual software that's mining the data. Again, pretty steady growth, and again, pretty large numbers here. Share of public cloud, we won't bother with that one. Now, this is the one I'm going to get to. Now, this is actually really interesting. If you look in there, these are just tons and tons of software, which is, to manipulate data, to adjust data, to clean it, to transform the data, to do the business intelligence on top of the data. And, that is a very large footprint of technology that and you can be pretty sure that most organizations would have probably a dozen of these in play, spread out, because it's very easy to download a BI tool and start playing with it. And you'll end up with pockets of it all over the organization. And however, they still have a common issue in that you need to write a transform to transform something into something the user can understand, and you then have to test that transform works. And that is absolutely fundamental. And for transforms, a typical transform for a large enterprise would probably be looking at maybe 16 tables in old table land if you're a relational database specialist. Those 16 tables in big data land could be a bunch of different big data stores linked to some actual reference data in databases. So it is a very difficult task to test, especially the concept of coverage and combinations. You know, everyone basically spends all their time hunting for those 16 tables, and then if they can't find them, they hack 3 or 4 of them to try and make sure it works. But when you're looking at the actual combinations of different scenarios, the numbers just grow astronomically, and you know, they just become so big you can't really test them by anything involving manual efforts, which is kind of where we come in terms of linking modeling and coverage techniques to design the data that's going to flow through. So these slides have come out a bit blurry, so what I might do is just pop down. No, it's still blurry. Okay. So this one here, you know, there's lots and lots of source databases, SAP, ERPs, you know, about 50% of the data is sitting in ERPs, and there are lots of specialist tools that will extract the data out of things like SAP. You know, you can use BAPI layers and all sorts of things like that, but you've still got to extract it, you've got to stage it, you've got to transform it, and actually inside that little blue box, you may well have 3 to 4 different types of transformations going on, which are then driving across. And then even when you say central metadata, you're going to check it with your central data, and if there are differences in terms of reference data, which might be cost codes or you know, fund codes or something like that, if those don't match, you're in trouble, and then you tend to bounce data back to the beginning again. So it's, you know, it becomes a significant piece of work. And if you look at this, this is actually very similar to to application migration. I think actually, if you look at when someone comes up with a bright idea of throwing away an old system and creating a new one and moving all the data from the old one into the new one, 50% of those projects fail. And actually, and that hasn't changed over the last 30 years. It's usually people get a bit too carried away in terms of what they're going to put into the new system. And also, they don't truly understand the data that exists in the existing system. So the data migration part suddenly becomes a massive problem, and just drags on and on and on and on. And then when it goes live, you know, you end up with lots of outliers, and it becomes, you know, and that tends to be when systems start to, you know, miss deadlines, and people in the end say, oh, well, forget it, we'll just keep the original system. So here you can see, let me just open the box up a little bit, transform and load, data cleansing, data extraction. Each one of those itself has to be tested. Basic approach, source schema, component under test, target schema. You know, this has actually been dragged in from, I think it's probably just someone we picked up from one of our maybe partners or something like that. And you can see there's a bit of a sort of cat's cradle of you know, information being passed around to make sure that, you know, it worked, and you know, that is no small task to set this up. Now, what I found is that these vary dramatically as you move around and you look at our customers, how they've actually set up the test frameworks for this, and they are. Test frameworks be over-egging it a bit. It's a few test harnesses with a lot of spreadsheets would probably be my characterization of a typical kind of framework. So let me I've just got a little VM here, so make sure it's up and running. Yeah, it's still alive. It tends to go to sleep. So let me just make sure that's still alive. I'm going to pop into the demo in a minute. So as I said before, you've got new data warehouse testing, you know, fact tables, dimension tables, etc. There's actually a really interesting point about data warehouses is that the person who's paying for it is the person at the end. So it's better to show them what the output is going to look like before you start doing the data migration. Now, to do that, it's best to synthetically create the data into your dimension and fact tables. You know, so it looks realistic. So your customer, your consumer, your trader is going to be able to say exactly what this system is going to look like. If you wait until you've migrated the data, then the chances are you'll be wrong and you've got to go back around that process. So I'm a big believer in doing the hard parts first, and doing the things where there's going to be the most user input. So must do your user acceptance testing before you've done the rest. So I would counsel that that's a good way of going about it. Migration testing, as I talk about, change requests. Now, change requests are massive. I would say we got, I think, one customer who it takes them, when they get a single requirement change, it takes them all day to go through all of their existing test cases by hand to see if any of them need to be changed, updated, removed, or added some new test cases. Now, that's for a single requirement. So how many requirements do they have? Hundreds. So they've got an army of people checking existing test cases. This does not scale. It's not really something that you can roll out in any systematic way and at speed. And as I mentioned before, report testing is kind of something that even if you go into a report and you just say it's the accounting credit, you might want to scrape that off a PDF. So you might use something like an eggplant or something like that to do some scraping of images, or a Ranorex or something like that. But that is going to give you a report amount, which you then need to validate with the input data. So that's your actual result, which needs to be checked against your expected amount. Okay. So best practice. This has been put together now. So if you look at what Sankar's done here, he's actually kind of come in and taken a look at a few things around the web. I would suggest that there isn't anything close to best practice at the moment. There are a bunch of harnesses which are better than others, but I haven't seen anything that actually kind of blows my mind here. So I think there is scope for, significant scope for an improvement in the best practice to do with ETL, business intelligence, big data, and report testing. And hopefully, when I show you later, you'll see kind of where we're inching towards that. With our tools, we're not looking to replace existing frameworks or harnesses. We're looking to inject quality and speed, and also improve the information that flows up and down those frameworks. So there are some very good frameworks out there. Don't get me wrong, Teleric's got some excellent stuff. There's some good stuff there. But when it comes to actually the quality of the information that's being provided into those systems and the rigor, that's where we come in. We would look to kind of load up those systems at the appropriate points to generate the data, to check the expected results, to harvest the actual results, etc. And then we would normally leave it up to those harness systems to do the aggregation up into the reporting systems. So this is basically, if we're looking at this, or the bottom bit is probably good here. So if you're looking at web log, streaming data, social data, transactional data, the problem you have is if you're trying to test that, you need to test them all in harness. You've got some web traffic. Someone's actually put some gone online and done some stuff. They got some social data about them, so you need to have a person that's actually gone in and done the web logs, because you might be able to mine some information about their club membership or their political affiliation or whatever the flavor of the month is. You've got live streaming data coming in from from the apps your apps that they might be using, and also you've got data sitting in the transactional databases at the back. Now, if you don't have those four in sync, you are not going to be having, you're not going to be able to test those. You're not going to be able to test the combinations. Now, if I said you go do that for those four things, now what you'd probably do is use yourself and actually push your data in and actually create a Facebook account, go online and order something. And, and that is just not scalable. You really need to kind of build the data that's going to force the data in through these multiple channels in a coherent and a structured approach. ETL, as I mentioned before, many tables and records to testing complexity, multiple sources. You've got data coming in all sorts of formats. I won't say unstructured. Data is structured. Even if it's just a Splunk log or some textual. If it comes in English, then that has some degree of structure overlaid on top of it. And it's just the test data creation is just a massively time-consuming activity. There's also very little data visualization, nothing in the automation space really, and the reusability of tests across. I'll show you a bit later on how we can actually drive the total number of amount of data you need to create to do the maximum amount of testing. It's also boring. It's so boring. why on earth would you want to spend your life doing this? You'd much rather be doing much more interesting things like modeling and building harnesses and frameworks, and going to work with users directly and then looking at the results in the system. It's a much better way than actually just sitting there creating very boring flat files at the back end of a system. Data lack quality and volume. The volume is a big problem. So when I say volume, there's a big volume, but a lot of the data tends to be the same, and that is very true of most production systems. You would be lucky to get more than 15% code coverage with your production data, and very little negative testing would go through that. So to do that, you need to create maybe another 50,000 rows of data, compared to 5 billion, but those 50,000 are going to hit that other 85% of your data. Data quality issues. Now data quality is a whole subject, and data quality is in the eye of the beholder, and which in this case is the tester. So you need to think about how you test. The thing with data quality is that you need to recognize it. You need to reject data which is of poor quality, and then you need to decide, okay, we have this poor quality data, what are we going to do with it? And then you need to create a transform which takes that poor quality data and does something with it. You could reject it, but the idea is you need to test your rejection routines to identify, to make sure that they will reject the poor quality data. Now, that's perfectly fine. People would do that normally. However, it's very unstructured and very unsystematic, and what tends to happen is the poor quality data tends to hit the system just when you're about to go live, just when you start to do the final tests, and then you're in big trouble. So you need to have tested it very thoroughly earlier with a much higher degree of rigor. Okay. Data quality, schema quality, operation quality. This is again 50% testers looking, manipulating, creating data. 20% of developers are waiting for data. If you have a dependency on another team, and we've seen this in action for a bank migration actually in Holland, where they had to do an entire bank migration in about 3 to 4 months. Now, each stage of the migration, there were 4 stages of the migration, and team B, C, and D were waiting for A, team C was waiting for team A and B, D was waiting for A, B, and C. So what we did for them, we actually generated data for A, B, and C, and D all in one go, and then we just strung it all together, and then actually managed to made them hit the deadline. Without doing that, they would have had to wait for the data to get all the way up to team D to be able to actually start even working. And actually, the other thing was that when they went live, it actually worked, because they'd done much more rigorous testing. So, what we've come up with is obviously we have a number of tools here, and I'm going to focus more on the functional testing here. We've also got an excellent tool called BlazeMeter, and BlazeMeter is all about performance testing, and performance testing is not just the number of users, but it's also that you have complex data scenarios to test the performance. So quite often you have these I guess the system just suddenly slows down, and you're usually finding that there's some particular combination of data that the database system is struggling with. You might have recursion down to a depth of 50, which has been actually just comes out of the data. It's got nothing to do with the data model. So to do that, databases just suddenly don't respond. Now, the only way you're going to test that from a performance point of view is to actually create those data scenarios in your database. So there's a lot of commonality, and with the CA tool stack, what we're actually doing is creating that tool chain, so you can do lots of help people build the requirements to performance testing, and the reality is you kind of need to do a lot of this in parallel. So, typically you're looking at gathering business requirements, and, this would be in bringing, in our terms, modeling the business requirements, validating the data's got transformed correctly, and this is the way that we do that is that we almost create a parallel transform. So we would create the expected results as well as the input, and then we've also then got a validation routine which would compare the expected with the actual. And then this is kind of more the stuff that with your harnesses would do in terms of how it would actually kind of work in the real world. Okay, so that's kind of that. So let me just go off and start doing a bit of a demo stuff, and hopefully my system's still alive. So let's just have a little look at this. Now, this actually is an abstraction of the data that exists in credit card companies. Now, you know, if you look at how most credit card companies actually construct their data, there are numerous sort of logical concepts, or in this case, they are physical concepts, in that you could have a business, the business could be a multinational, it could be just a single country, they could have multiple addresses, they could have a single address, and you've got all sorts of different combinations of data lurking around inside there. Then you come down to actual card holders, and you could have multiple business card holders or a single business card holder, and those could have single cards. They could have combinations of credits and debits. They could have multiple cards. They might have, you know, a personal card, and they might have a business card, all rolling up to the business, and that's very common with small businesses. And then you have these things called billing accounts, because you might separate the bills out into separate areas, multiple single, and then you've got the risk accounts, which are the things that the auditors are interested in terms of balancing, you know, the credit ratings and not credit ratings, in terms of how much money they are allowed to spend on the card, and, you know, all of the default sort of modeling, et cetera, et cetera. Now, if you think about this, the way that we've done this is that we've actually gone in. Is that we've gone in here and we've actually just created, for those of you who are familiar with the TDM tool, we've got a bunch of, let me just come in here, let's just look in here. Each one of these is a publish, and all we have to do is just drop that onto the screen, click OK, and now we've got a publish. Now a publish is going to make the data. So what we've done is we've blended what was in the TDM tool into the product. So let me just take that off. If I come into here and just go and have a look at this, you can actually go in and see what this publish is going to do. Now, the publishes, for the most part, when it comes to ETL testing, a lot of the data you don't really care about. It's just as long as it's data that's valid, and that is using one of our data painter functions, and that data painter function there is, if you haven't overridden me, which is what this bit of logic does, then go and pick up a value from the target schema. So you've already got some data in there. I don't particularly care what the data is for the purposes of my testing, so just go pick me up a value, and I'm happy. So the way that we construct the data publishes, and there are some accelerators to do that, and all you have to really do, it's very straightforward, is just come in and say, I need to create, let's create one for, let's just create one for address, and we've got these various things, and I could just do a general publish. No, let's do this one here. And what we can do then is, just to make this a very rapid, as you saw before, if a variable is set to override, otherwise pick from a random target value, and if I just go off and do that, we will just create you a data generation sort of module very quickly, and I can now drop that onto the palette just like I did before. I could create some variables. If I create variables, that allows me to then override those values. Okay, and I'll come back to this one in a minute. Now, coming back to how you build test cases for particular scenarios that you want to test. Now, you can do it scenario by scenario, and here what I've done is I've created the most simple one, which is basically I've got one of everything, no multiplications apart from multiple cards. BC Germany. Now in this case I've created a headquarters in Germany, and this one I've just created, I've made sure that I've picked up some of the decision gates. So this is just a slight variation where I've actually looked to make sure I've got the different combinations. Now a lot of ETL testing is to make sure that you have a specific value, and a value has been transformed correctly. But the really hard stuff, and this is where the data builder tool comes in, is when you have multiple rows of data. So you've got one-to-many to one-to-many. So I might have, all right, I want a customer, I want a new order, I want 3 items in the order, I want 2 to have been shipped, and I want 1 to have been returned. So you've got a 1 to 1 to 3, and then in the 3, you've got a 3 to so 2, which is the 2 shipped, and then we need a 2 to one of them to go to a 1. So creating all those different combinations of repeaters is very difficult when it comes to creating the test data. And that's where basically you can see we've got all our repeaters in here. So all we have to do is just tweak one of these repeaters, and we're going to create you multiple businesses. So it's very easy to do that, and all you'd have to do is, for this repeater billing accounts, in our little test data here, we're just saying multiple or single, and we're just adjusting those numbers. You could, of course, for the multiple, you could make it a random number, bigger than between 2 and 10 if you're interested. Now, that gives you scenarios, and that's all very nice. Now, what was a much better way to go is to start thinking about creating covered sets of data. Now, the covered sets, for this particular set of credit card testing, there are 192 potential combinations of data that you could create. And those are apps. This is the real world. This is possible. And that's something that you could think about doing, and that would in effect create you all of the different scenarios, and then all you'd have to do is just run your transforms and make sure that the 192 all appear in your business intelligence system effectively. So that's one way of doing it. You could also say, well, I just want to make sure that I've got an example of each decision gate, okay? So that decision gate means I've got a multiple, a single, a multiple. So although we're going to merge them together, you can see the number has gone down significantly. Now that would allow us with 3 different customer accounts to test all of those different scenarios. And this is the idea of using coverage to drive down the type of data that you have to test as much as possible. So that would allow us to just create three sets of customer accounts and test 196 of the potential, combinations. You can play around with these numbers, and there are different types of coverage techniques. You might want to just base it on what exists in the users, or you might want to do something like an all pairs, which is a all paired. Let's just give that a go. So you've got an all pairing of values, and that's going to make sure that each one of these is paired up. So a multiple would come with a multiple would come with a true, a single would come with a multiple, a single would come with a single here, and there you would get 10 of them. So you can see that's actually a pretty good one for when it comes to data testing in terms of being able to create a smaller set in terms of how you would do that. Now let me just show you a transform. It's always better if you have to see something real. So what we have here is some addresses, okay? Now, what I've done here is we've got some addresses that are sitting inside a database, and for the purposes of this, we're just going to be generating one table. We would normally be generating 10 to 12 tables, but let's just stick with one for the purposes of this. And here we have a transform. Now you'll see we've got, this is actually a view which has an address transform, and you'll see here that the postal code has actually got some manipulation going on in there, and it's very common to see this type of manipulation. So here in transformations, it could be merging of columns, it could be if statements, it could be case statements, and actually, if you go and look at, let's just go and look at the views for this one. We go to this view address transform, copy a create statement, just pop that over here. You'll see here that we've got this case statement. Now this is a relatively simple case statement. Depending on the country, we're going to do some manipulation in there, but the reality is these transformations can be very complex, and especially when you're dealing with joins. Pick out the highest value in a week and post that as the maximum amount that the customer has spent in the last week for the purposes of credit ratings, etc. So that's the transform that we're going to be testing. Now what we have here is we've actually done a bit of modeling. I'll just quickly show you how we do it. We would go into here, that little address that we dragged on before. What I would do is I would just drag it onto the palette. I'd say create some local variables, and that's going to do that. And then I'm just going to nip in here and do that. And then all I've got to do here is I'm just going to go in and I'm going to overwrite. What I really care about here are the whether is to do. There's a little thing they call data builder, is whether it's a US or whether it's non-US. So in here, I could just come in and literally just type in the US, okay? Now, that is pretty much all I need to do for the purposes of creating an address, but what it hasn't done is given me something to tell me my expected result. So what we do, and this is becoming a more common technique, what we're going to do is we're actually going to create you a shadow table. So let's just see if I've got it over here. And here what I've done is I've created a shadow table which is called expected address. So you know, it doesn't have to be in the same schema, but you can store the expected results inside the Agile Designer meta tables, but actually sometimes it's just easier to create your own versions of the table so you can actually compare column to column, and it's just much easier to see what's coming out. And here we're going to populate the expected address. Now, under these circumstances, all I have to do is just go in for my address. Now, this is the publish that we were working on. That was created for us by hand, by the accelerator. And again, I don't need to worry too much about it. And all I'm going to do is just come in and just do expected address. And I'm just going to come in and do that. Now, what you're going to see is things like address ID. All I have to do is pick them up from the other table. So I'm going to map these over to the results from the other tables. Now, again, for this one, I can just do the same thing. And you're just going to repeat this. Now, we do have some accelerators for this as well, which are just going to help you fill it in. The thing that is most interesting here is the postal code, and that's where I'm going to actually do some manipulation of the data. Now, just to save a little bit of time, I'll show you one I created earlier. For all of you Brits, that's a Blue Peter moment. So if you come here, you'll see that what we've done here is that we've, let's just go into here, address. So what we've done here is I've actually made it a little more sophisticated. So for the US address, I've just changed the country to UK and US, like so, which is all good. And then over here, I think this is a publish. Let me just make sure it is. We've actually got address and expected address. So we're going to populate our address table, and for our expected address, we're going to just copy all the values directly over, with the exception of the postal code. Now, the postal code, and this is where the power of the TDM engine comes in, because we've got a very, very sophisticated modeling or data manipulation language, which is pretty much a full ETL tool. It's got an incredible amount of stuff in there. It's also, you know, got lots of seed tables and things in there. So it's going to pull in, if I just pop back to the address, you'll see here that for the let's just go and look for the postal codes that we're actually creating in here. We're actually picking up a random list of zip codes and a random list of UK postcodes. So you don't have to manipulate those. We've already got those. So, you know, that's just a matter of coming down here and saying, go pick some data up from seed tables, and you can pick them up from there. You can pick them up from another table, whatever you want, really. Okay? But coming back to our expected address, here, this is the transform. So that we are, in effect, mirroring the transform that this is occurring in the view. So we're saying if it's US, we're going to put in US zip, like so, and then we're going to pick up the postcode, all postcode, and then we're going to pick up the postal code from the other table. So that is being brought in, and this is the manipulation. So you can basically build this to, you know, an incredibly sophisticated degree in terms of the types of transforms that you can do that. Now, what does that mean? So we come in here, we've modeled it, and what we can do then is we can say, right, I'm going to now, based on my different transforms I care about, I'm going to nip off, and I've got two of them, one with the US and one with the UK, like so. Now, all I have to do at this stage is I'm just going to go in and say, run them, go make me some data. So I'm going to make some data, and I'm going to, what environment do I want to put them in? Dev. And I'm going to create a test group ID, which is going to be, let's just call it Sprint 1001. How many do I want? One. So I've got Sprint 1001, and I'm going to fire that off. And what's happening now is we're actually just going out and physically creating the, think about this, we're creating the data that's going to be pushed into our real transform. And at the same time, we're also creating the expected results. Okay? So we're actually creating the input and the expected results. So you'll see, give that 1 second. So you're seeing that we've actually, somewhere down here. Oh, it's doing both of them. So what's happening now, because we're doing the UK and the US one, we're doing two of them. So if we just go up a little bit, we won't see it. Yeah, so it's actually putting the values out there as well as it's coming out. So there's the rows that we created, and we have now finished. Okay, so we've created our data. That's all nice. And, oops, it's all done. Now, if we go into here, what we'll actually see is that we come and have a look at these and we look at, say, Sprint 101, we've actually now, we've got our address ID, so this is the input key for that one, and for our UK one, we've got 1,309. Now, what I've also done is I've kind of cheated a little bit. I've actually said, just to make sure, I've stored them inside the data builder logic, sorry, data builder meta tables, and I've actually got the value in the address table, which is the input to our test transform, and then this is the expected results, and in this case, it's just gone to the table expected address. So I've done that. Actually no, let me just finish on what else we've got going on in here. Now, so if we look at our expected address, we've got this. If we look at our, let's look at our view, which is address transforms. Let's just make sure we've got that. Let's just go, let's just do address transforms. So you can see here we've got some transforms that have come out. Now this is the real system. This is actually what's happening. And then over here we've got the actual input to them. And now we've got to work. Now what we've got to do is work out did the transform work correctly. Now we've got our expected results. Here's our expected results. So the bit that we have also got in the tool is the thing that will actually test the transforms. Now the way that we do that is that we actually create a transform table, and the transform table basically will go off and execute the transform. In this case, it's just a view, so it's very simple. We're just going to look up the postcode. Now here's the magic. The magic is that because we know the primary keys or the unique keys of the input data, then we will automatically blend those in for you. So you've got a bunch of input keys, and that's going to give us that. Once that's run, we store that information, and then what we've got to do is we've got to then create, we're going to go and see, do they match? So that's our expected address, and that's the actual address. So we need to make sure that, sorry, this is from the view, which is the real transform, and that's from that, like that. Okay, so what we've got to do then is, what we have then is we have a little, now this is our tool called Agile Designer Automator, and what this will do for you, this was actually going to go through and it's going to actually do the testing for you. It's going to go and say, we know the keys we're importing, we know our expected results, let's go and put the keys in, run the transform, let's go then and run the keys that we've created and use those to actually do the comparison. So this is a very, very powerful tool, and you can tweak this and adjust this. You can incorporate this into your existing framework, and you can see we've got lots of juicy logic sitting in there. And what I have to do is I'll just run it in a batch mode, and I'm just going to say X-ray 6 is the run ID, test address, address transform is the group of transforms that we're testing, and the test address is the name. So that is the name of the data that we created, okay, which I did earlier on. I think we call it Sprint 1001, but I'll just do it with some data I had before. So if we just run this, so this will chunter away in batch. It will merge the data that you require for your transformation. It will stick it into the transform itself, run the transform, and then at the end it's going to go off and actually check to see if your transform worked. So pass. And what you'll see there is that actually what we have here, is we now store this information. So we've got X-ray 6, which is the run ID that we were running. It's gone off. It knows the transforms that we care about. It's got a bit of logic in there. It's got some exact results. Pass, like so. And there we have our transform being running. So it's a very structured way of thinking about transformations. Now, just one other thing before I just finish up. The other thing to think about is that when you think about whether a test has run, and this is actually one of the magic moments here, is that you've got something called, I know exactly what the expected result is going to be. In most cases, you sort of know what it's going to be. You might know it's a credit, but you haven't really modeled it down to the nth degree. You might know that it posted a transaction, but I don't really care what the transaction is. I just need to make sure the transaction posted into the system. So in that case, you might just say exists. That's all you care about. You don't need to know the exact value of it. So under that case, what we've done is we've created three different 3 different types of validation of the results. It probably worked, and it possibly worked. And that's allowing you to come up with a sort of conditionality on the type of results. So you might say, look, for initially, we're just going to say it posted, and that's all we care about. And then as you have more time, you might want to make your modeling a bit more sophisticated and be able to put in additional, maybe go straight to the actual result itself. Okay, so and all of that is handled by our harness. You don't have to, once you've switched into this methodology, the harness could run a Ranorex script. It could run, it could run a dev test script. All we have to do is just make sure that we can pass you in the keys and also the expected results, and you also pass back to us the actual results. That would allow us to do the comparison of the information. Okay. So now just one other thing, which is worth just mentioning. If you look at this example, what you'll see here, this is actually, sitting inside here are actually some pretty complex transformations. But when it comes to modeling, the only things that I really care about, in terms of the transform themselves, are whether the warranty, the serial number is 11 characters, the IMEA number is 11 or 10 characters, so I just modeled that. And then when you go down to, you want to see whether they have a product service agreement or whether they have a notification, okay? So if you look at the potential for all possible, there are 8 if you go to all combinations, but actually what for this one, all we really need to do is to come up with 3 of them. So we only need 3 warranties created to test all of the transformations, and I think there's maybe about 80 transforms going on in here, because we've merged them. And the only thing you really care about, there's a lot of transforms, whether you have a notification or whether you have a product service agreement. So you would only have those tested if those are true as you go down that route. Otherwise, they're all set to null. Okay, so you can kind of, by using the optimizer, you can significantly reduce the amount of test cases that you need to do and really, really focus on high quality data to drive through an automation framework. Okay, so let's just quickly go and just jump into slide decks. I'm just about finished here for the moment. So we'll send out the 2 slide decks just to give you an idea for you guys who are ARD customers. If you have the automation, plugin, which allows you to create automation scripts, then you will get Data Builder. So that will allow you to generate the test data you need. Now, initially, what you may focus on is just making sure that you generate the right test data for your automation scripts. In my mind, it's probably going to end up being about 30 or 40% this, and the rest of it's going to be business intelligence or report or migration testing. But a good place to start is to stabilize the data that's going into your automation frameworks, and that's generally what this whole, this lends itself very well. Automation frameworks are incredibly fragile. They're so data sensitive. If you get the data wrong, it all comes crumbling down, So you need to spend a lot of time actually making sure you've got finding the right data, and the tool can do that very easily for you. It can look up data as well as making data, and that allows you to, and it can also reserve data, so you don't get automation frameworks stepping on top of each other. In ETL land, you don't get people transforming big data, because we'll keep track of which keys have already been used and allocate them out, etc. So these are the kind of common use cases. So it's a new set of features inside ARD. It's in effect, it's a sort of almost a new product, Data Builder. So there was a little bit of setup. You do need to create some meta tables in a schema somewhere, because we need to keep track, and those are those tables I was showing you. We need to keep track of the mappings, the transforms, the keys, and actually the results, which was that X-ray thing I was showing you. We also split the publish up slightly. So if you're a TDM user, we actually build all the primary keys before you start. We do the publishes and the finds. Usually we do the find first. If we can't find it, we'll make it. And then what we'll do is perform any post actions like sum, average, etc. And as you saw, the stored keys then can be used to drive the test, because we know the data that we created that is going to feed the test. We've put in a load of accelerators. We're trying to, to make you from being able to test 1 or 2 transforms a day to be able to test, 50 to 60 transforms, maybe hundreds of transforms. So we're looking to significantly increase the throughput and reduce the time that you'd have to spend manually manipulating data or doing any manipulation. And that's really what it's about. It's about really speed, reducing the amount of data that you're actually having to create and massively improving the quality. And I think also the idea of being able to create a structured framework which can be applied pretty much across all of your testing lands, where data is provisioned at the beginning, tracked as to what data is used, tracked your expected results, run your automation or transformation, harvest the results and compare them, in a structured way, is really the only way this is going to scale out and is going to drive, different behavior in the testing community. So just a quick summary here as I just finish up. So those of you who are familiar with the TDM tool, subsetting and masking, kind of core TDM data archaeology, which is kind of, looking through the data, trying to understand the data you have. Cloning data, very popular technique. Test data on demand, which allows you to just go to a portal and just request the data you want. Again, that's more scenario-based. Data reservation and data generation. And then ARDs, obviously all about automation. You can model data flows. You can design test cases, automation scripts, and RR endpoints. And then what we've added in the middle is that we've kind of using the generation from the TDM engine. We're obviously providing a lot of the automation support. We've also got a new method of reserving data, a much lighter method than the TestMart. And then obviously you've got data flow modeling, and data design built into the data builder engine. Okay. So I think I've probably been going at the rate of knots. So I'm just about finished here, I think. So I would just say that this is a rerun, actually, because we had a bit of a problem with the recording. I would just say to wrap up that this is rolling out towards the end of March. However, if you are interested in having a more detailed demo, then just let us know. We're also doing a soft rollout in that we've got 2 to 3 customers that are already using this, that are starting to kind of work with us to kind of build out and get it integrated into their world, how it's all going to fit together, etc. Okay. So that's it for me, and I don't think we're going to go back to Melanie. I think we're just going to finish up for today. So thank you very much, and hopefully you found that interesting. Any questions, just ping me or your CA sales guy, or just contact anyone in the Agile Requirements Designer team. Thank you so much.